Timo Karppinen, hi. Now we could modify our code for adding a control for an LED output. So modify it for some more lines, for values in voltage and for controlling output. And saving this again with a new name, so more precision and LED output. And for controlling the LED, I'm putting here after this variable definition also a definition for our LEDs. So this is an LED pin, and LED pin is the 13, so it is exactly this LED on the board, which is in the address 13, digital output 13, like in most of the Arduino boards. And then another integer value, which is the LED state. And that integer number gets a value low. How could an integer get a value low? So in the Arduino environment, there is a definition file which is defining that the keyword low corresponds to an integer value 0, and the keyword high corresponds to an integer value 1. That's the way of controlling the LEDs with an integer number. So the language C doesn't actually include the Boolean variables. That's why we are using the integer 0 and 1 here. And then still we need to define here the pin mode, that it's an output pin, this 13 pin. So on the setup, in the end of the setup part of the program, I'm adding here a line that the pin mode, so this is the pin mode function from the Arduino environment, so let pin gets a value output. So with this pin mode function, we are actually writing to a processor register, which is defining if one of the digital input-output pins is an input or an output. And now we define that it's an output. So set as an output, like this. And then we go and modify the web page that we get like a control for the LED variable. So let's add here a line in the website that you can click and change the value of the LED. In our code we go to a line where we added this text explaining the decimal numbers. So I'm adding here a few lines to make it a little bit more like visible that here are the controls. And then I start by printing there the status of the LED, that what is it at the moment. So LED is at the moment in state, and then space there, and end of this string. Also, it's better to make it a little bit more visible in the website. So client print line, and there are 2 breaks there. Like this. And then LED is at the moment in state, and then the status of the LED, so client print line, and the variable that we created, the LED state. So now it is printing the LED state on the HTML page, which is the LED state is originally low. We can actually test that if this is working correctly. So compiling, and then compiling with no error messages and uploading to the board. And then putting the serial monitor on and stopping the browser and starting with the new reloading. Web page is not available, just a moment. I have a look on the code. Actually, there wasn't anything wrong with the code. The code is completely correct. So sometimes it happens that when you upload your code to the board, and then after the upload, it will start the program on the board automatically. And if you are too fast in going to the tools and serial monitor, you won't get it somehow running correctly. So then if the board stops working, you need to disconnect the USB connector, so to get the board powered down, and then it is disconnecting from the Ethernet completely. Then you reconnect the USB, so putting the power on the board, and it will start the program there from the beginning, and it is connecting to the Ethernet. So the Ethernet router will recognize that there is some activity on the connector, and then after that you start the serial monitor, and the serial monitor, when it is active, it is starting these lines here, which is establishing the web server there on the board, and then it starts running again. So there wasn't anything wrong with the code, I just like restarted the board and then it works. So we have here the text that the LED is at the moment in state 0. You see there is the number 0, which is an integer number 0, and we are writing here that the print line LED state. So the LED state is our value low, and which is actually the integer number 0. Now we will add here on the website the lines where you can click to turn on and off your LED. So client print line. Okay, let's make here a break again so it's easier to recognize on the website. So 2 line breaks there. And then client print line, and then we start like creating on a website a link to another website. So there is this kind of href equals to, and now it is like when I click the piece of text, this web server client is sending a string to a web server. Typically here there would be an address of a new website or something when you add a link to your text in your website. But here we put there that this string contains an quotation mark. So this is that there is a quotation mark here, and this is a text that let on, and in the quotation mark and then this is the text there on your side, turn on, and end of this A here. And end of the string. Like this. So there will be on the website a text turn on. And then it is, when you click the turn on, it is sending this string to the web server on the Arduino board. And let's do another line, which is then the turn off. Copying the first one and then another one. So turning off your LED. So, I'm sorry. LED off, turning off the LED. And then we will create a string variable. And so so when the web server client, so your browser is sending this string to the web server, then we read this value to a string variable. So let's go into the beginning of the code where we defined all our variables, and then creating here one string type variable, and this is my read string, and explaining here that this is the string for reading LED state from the browser client. And how to get the client string into this one. So we studied the code, the original Ethernet example, and we can find out from here that there is in this loop, so there is a client read, and it is taking it on the character type variable C. And in that one, we can then add here that our read string, so read string, that's our variable. So every time it is executing this if statement, it is adding there into my string the characters from the variable C. So this is populating the string with characters from variable C. So this is my command. So populating the string with characters from variable C. So my read string gets these characters from the client, so the web server client. And then we go into the code. So after reading these characters to the read string, we go and test that if it includes this text, the let on or let off. So we go here into the end of this loop, which is continuously executed. So we add our code in here. So in the beginning of the code, there is a setup part which is run once when you start the processor. So you connect the power on the processor, so it is running this setup part once. Then it goes to a loop, void loop, and then inside here is an empty bracket, so there is no values here. So this is a loop which is executed continuously as long as the processor is powered. So here we were populating our read string with the characters from the browser client, and now in the same loop then we are testing that what is included on those characters coming from the browser client. So we start from here, so testing it. So if the read string dot index of so this is the read string is like a class, and then there is a method index of where it is looking at the string for looking for certain characters there, and we are looking for the characters let on. And if it is finding these in the string, it is responding with the index of those. Is it the first character, second, third, and so on. So if it is there, it is definitely bigger than 0. So that's what we are testing. And we continue here with the putting the what is to be executed if this is true. And we set our let state that we set to high. And then we to digital write let bin and let state. So if you don't know how to write to digital output, you just have a look on the Arduino.cc, go to the learning and reference and go to digital inputs, digital outputs, and then you will see that how to write to an output bin. Sorry, there is not a capital letter but a small letter here. So let bin gets the value of the LED state. And still I'm writing to a serial board that what is happening. Serial and print line. So this is actually just writing to our serial monitor. So LED is on. So this goes to just to the serial monitor. So if I can't get the browser running, I will see at least in my serial monitor that what was happening. And if this if statement is not true, then I do another set of commands in here. So it is almost the same. So it is this. Copying that one from there. And let's say this. Low and let this off and so on. But yeah, but I have a thought that I will test that else. And then testing again if read string index of let off is bigger than 0. Then I will do the next 3 statements. Now it is testing if I have got the LED on or if I have got the LED off. And that was the end of this if statement, and then I need to add the end of my else statement here. So that's the else and end of the else statement. And after this testing, I will empty this read string, waiting for the next push of these buttons, or not the buttons, but the line of the text here, the linked text on the website. So this will write there in the read string an empty value. It's time to test if this is working correctly. So compiling first. There is an error on the code. Read string was not declared. Wait a second. Read string is not declared. So I have an error here somewhere on my definition of the variable. String read string. The error is here on the string variable definition. So actually here in the end of the code we were using a class string, not a variable of the type string. So you see there is an read string dot index of. So read string is an object which got a method index of. So read string should not be a variable but an object. And then there is a string class. So capital letter S here. And now this is a string class, which is, I'm now defining an object which is from the string class. So now this read string has got a method, the same method as got the string class, and one of the methods is the index of. So let's see. Done compiling, so no errors. And uploading. And tools and serial monitor on. Stopping the request and then reloading the page. And now I have here turn on and turn off. And the let state at the moment is 0, and turn on. And it is changing the let state to state 1. And this picture of the Arduino Leonardo ETH board is just a still image. This is not a video, but I can ensure that this LED is now on my board. And turning off, and on the next update this state is 0, and turning on again. And we can see the same in the serial monitor as well. LED is on, LED is on, turning it off, and on the next update LED is off, and now it goes to the web server client as well. The LED is off. So it works. So if we go still through the code that how all this was done. So it was done in a way that I created an read string class here. Sorry, there is a string class, and I created an object read string. And then I'm populating that object with the characters from the browser client. So your Internet Explorer or Chrome or Firefox or whatever web browser client. So this client is sending some characters to the server, and those characters are here on the variable C, and I'm adding those characters in my read string. And then I'm testing if this string contains an text let on. So read string dot index of let on. So if it is part of the string, this let on, then the index is bigger than 0. So I'm testing if the index is bigger than 0, then let state is high, and I'm on the board, I'm writing to the let bin the value high, so the let state. And at the same time I'm also printing on the serial monitor that let is on. Then I'm doing the same test for the string let off, and writing that let state is low and let is off. And to be able to change those values on the HTML document here, this turn on and turn off, I'm creating here like a like you typically put a link on your website, so that when you press with the click on the mouse here, you're actually sending this string led on to the web server, and the web server is at the moment on this small computer board. So this is how it works. And now it's your time to start playing with our miniature web server. So instead of controlling a LED, you could control, for example, an lighting of your room. So if you have a low voltage lights, so low voltage LED lights or low voltage halogen lights in your room, you can add a small relay board on your Arduino and control the relay on the Arduino with this code, and then connect on the relays your LED lighting circuit or something similar. So it's up to you. Thank you for following. Bye.